All right, today we are going to learn about more two-step equations. We were actually doing two-step equations the last couple days using the reverse order of operations, SAD, me, P, where we would take an equation like 3x plus 2 equals 11, and we would solve it using the reverse order of operations. An equation like 2 times w plus 36 in parentheses equals 114 is in the form of p times x plus q equals r. It contains two factors, p and x plus q in parentheses. It is considered a two-step equation. It says solve these equations using the properties of equality. First, I want to show you how else you might be able to do this equation using the distributive property. This says 3 times x plus 5 in parentheses. When we've seen this in the past, we've used the distributive property to get rid of the parentheses. You don't need to write this method down. We'll only have you write down the two-step method. But watch what happens if I use the distributive property. Let's take a look at how many steps that was. Well, when I look up here, it says this is a two-step equation to solve this problem. So let's take a look at the problem a different way. So 3 times x plus 5 in parentheses is equal to 45. If we think of SAD me P, we might look at this problem and go, okay, I see adding 5, so therefore I'm going to subtract 5 on both sides first. Unfortunately, that's not going to work the way that this is because the plus 5 is in parentheses. And since it's in parentheses, actually, you would look down here all the way to the right in SAD me P where the P is. That actually comes last. So I don't want to do that first, so I am not going to do subtraction and addition. Instead, I'm going to move on to the next thing, division and multiplication. If you look right here, 3 is being multiplied times the parentheses. Therefore, I'm going to do the opposite of that and divide by 3 on both sides. 3 divided by 3 equals 1, so I have 1 times x plus 5, or just x plus 5. This is equal to 45 divided by 3, which is 15. Now, I have a one-step equation with addition in it, so I'm going to do the opposite of what I see, which is to subtract 5 from both sides. Positive 5 and negative 5 cross out because they are opposites, leaving me with x. And 15 minus 5 is 10. Notice we got the same answer as when we used the distributive property. This is not going to get you a different answer. It's going to get you the same answer. It's just going to get it for you in less steps. Look, the first step we did was to divide by 3. The second step we did was to subtract 5 on both sides. So only 2 steps instead of 3. So it is a faster, quicker way to the same answer. Let's take a look at example 2. Again, we could use the distributive property on this problem, but we're not because there is a faster way to do it. 5 times n minus 2 equals negative 30. Because the minus 2 is in parentheses, we're going to go and move to multiplication and division first. We are multiplying by 5 outside the parentheses here, so we're going to divide by 5 on both sides to get rid of that. 5 divided by 5 equals 1, so I'm left with 1 times n minus 2, which is just n minus 2, and then negative 30 divided by 5 equals negative 6. Remember, different signs equals a negative answer. Now I see n minus 2 equals negative 6. The opposite of subtracting 2 is adding 2. So we're going to do that to both sides. Negative 2 and positive 2 cross out, leaving me with just n. And negative 6 divided by 2, or I'm sorry, negative 6 plus 2, different signs mean I'm going to subtract and take the sign of the bigger looking number. The bigger looking number is negative, so my answer will be negative, and 6 minus 2 is 4. So n equals negative 4. That takes us up to the first 3 letter problems. But let's take a look what these problems look like if you have rational numbers like fractions and decimals. It says sometimes the factor p in p times x plus q will be a fraction or decimal. Solve 2/3 times n plus 6 equals 10, where n plus 6 is in the parentheses. Well, like before, we could use the distributive property. But let me tell you, if I use the distributive property on this problem, it is going to become difficult. Let's take a look at what it would be if we do this as a 2-step equation instead. So again, you don't need to copy down this one. Copy down the one over here on the right. Instead of distributing 2/3 to n, we're going to say, okay, because the plus 6 is in parentheses, we're going to get rid of multiplication and division first. The opposite of multiplying by 2/3 is to flip it and multiply by 3/2 on both sides. 3/2 and 2/3 are reciprocal fractions that when multiplied together equal 1. So we have 1 times n plus 6, which is just n plus 6. Then on the right-hand side, we have 10 times 3/2. Again, you multiply by the top number, divide by the bottom number. So let's do the division first, because 10 divided by 2 comes out to be 5. And then 5 times 3 is 15. Then you can subtract 6 on both sides. Positive 6 and negative 6 cross out, leaving you with n, and 15 minus 6 is 9. So I was able to do the same problem and get the same answer, and not only was I able to do it in 2 steps, I only had to multiply one number by 3/2. So I only had to multiply by one number by a fraction, where over on this side, I had to multiply 2 numbers by fractions. So again, doing this as a 2-step equation is quicker and faster and smarter. Take a look at example 4. It says 2/10 times c minus 3 equals negative 10. I'm not going to show you this one with the distributive property. The opposite of multiplying by 0 and 2/10 is to divide by 2/10 on both sides. 2/10 divided by 2/10 equals 1. So 1 times c minus 3 is just c minus 3. Then you have a negative 10 divided by 2/10. That's going to give me a negative answer because the signs are different. And then I could pull out my handy dandy calculator and put the 10 in the calculator first and divide it by 0.2. And that's going to get you your answer. Or you can just recognize that you can move this over one spot and add a 0 to the top. And 100 divided by 2 equals 50. So c minus 3 equals negative 50. That's a 1-step equation where we would add 3 to both sides. And after we add 3 to both sides, negative 3 and positive 3 will cross out, and c will equal negative 47. That takes us up to the letter problems on the bottom of this page. Let's take a look at the word problem at the top of page 484. Jamal and his 2 cousins received the same amount of money to go to a movie. Each boy spent $15. Afterwards, the boys had $30 altogether. Write and solve an equation to find the amount of money each boy received. So, when we've done these word problems in the past, we would first ask, what are we trying to find? We are trying to find the amount of money each boy received. And so we would underline that in our word problem, find the amount of money each boy received, and we would come up with a variable for that. I think it makes sense for M to be our variable and for that to stand for money each boy got. Now that we have our variable, the next thing we've been looking for is a total. That number to go by itself on one side of the equal sign. So I go back and I look for my numbers. First, it says Jamal and 2 cousins received money. Well, hopefully you see that that's not 2, but 3, because you have to include Jamal. So it is actually 3 cousins altogether, Jamal and his 2 cousins. They received the same amount of money to go to the movie. Each boy spent $15. Afterwards, the boys had $30 all together. Now, if I look at those 3 numbers and I ask myself, which one of those sounds like a total? My eyes are drawn to the $30 altogether. Because first of all, there's this word afterwards. And secondly, the word altogether. Altogether just sounds like a total. This is what we have altogether. Plus, the word afterwards means this is what happened in the end. And oftentimes where you end up is the total. You could either be where you end up or it could be where you start from. But if you end up someplace and it's all together, that's going to be the total. So we're going to put $30 all by itself on one side of the equal sign. Now we got to take a look at the other numbers we have. It says Jamal and 2 cousins received the same amount of money. We know in this problem that M represents the amount of money each one of them got. We also know because there are 3 of them and they each received the same amount of money, we would have to take the amount of money each boy got and multiply it by 3. But let's take a look at this other number, 15. It says each boy spent $15. That means the first boy spent $15, means the second boy spent $15, and Jamal spent $15. Well, they each spent $15. So I would actually have to multiply that times 3 as well. So now this gets real confusing because I'm multiplying both of those numbers by 3. Well, we know if we can multiply 2 things times 3, we could actually put them together in parentheses. So we could put the M in the parentheses, and we could put the 15 in the parentheses. The question is, what would I do with those 2 things? Let's take a look at it. They each received money, and they each spent money. The key word here is that they spent it. We're going to subtract those 2 numbers. So each boy received an amount of money, M, and then subtracted by spending 15 of it. And all 3 of them did it, so we would multiply that times 3. So our coefficient gets multiplied both by the variable and by the minus 15. Well, now you can see that we have the two-step equation type that we've been doing in the previous problems and examples. So how would we solve that? We would divide both sides by 3. And I'm going to tell you what we're doing as we do this. When we divide this by 3, we're going to take and make this problem no longer about 3 people. It's going to become about 1 person. Look, 3 boys had an M amount of money and spent $15. When I divide this by 3, we're getting rid of the 3 boys and we're making it all about 1 boy getting money and spending $15. Instead of 3 boys having $30 left over, when we divide that by 3, it's 1 boy had $10 left over after he spent his $15. What if he didn't spend that $15? Well, we would, instead subtracting it, we would add it back into what he had left over. And we'd find that he was given M amount of money, and that was 10 plus 15, or $25. So each boy received $25.